Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning to all.
Madam. Good morning,
Right.
madam.
Good morning. How are
Hello,
you?
madam.
How's
Good
everyone?
morning.
How's everyone today?
Fine.
Quite good, quite good.
Okay, Alhamdulillah. I hope everyone is okay. It's good.
Alhamdulillah.
Okay. Believe it or not, we are now in week 11. All right. Week 12, isn't it? What week are we now? 11 or 12?
11, madam.
11,
Okay,
madam.
11. Okay, we are in week 11, isn't it? So we have another one more month. Okay, before the end of the semester. Okay, I hope that everyone has perhaps some people have already finished doing the assignment, because I've already received submission already and started to receive submission of assignment 2. Okay, in ULearn. Okay, so for those who perhaps on the way doing the assignment question, so please just make sure that you are aware the due date will be this Friday and this week Friday. Okay, so if you have finished, then make sure you just upload. Okay, and again, just to remind you, everybody must submit their own work. All right, make sure you have your own individual assignment. All right, and of course, submission will be done by group leader or group representative. Okay, in PDF format. So I hope to receive everyone's assignment by this Friday. Okay, as far as the test is concerned, I am still marking, right, the test paper, the test script. Okay, I'm a bit I cannot mark fast, all right, because everything is actually is a soft copy, so it's actually is rather, not to say difficult, but it is actually is a bit tedious. Okay, because of because of it's a soft copy, so we can I myself cannot actually mark very fast. But anyway, I am hoping to actually finish marking by this week, hopefully, before I got your assignment too, because then it seems that marking has to be done like continuously, until the end of semester. Okay, as of today, perhaps we are going to continue our lesson. Oh, by the way, before we continue the lesson, just let me to inform you regarding um, our what do we call tutorial. Okay, tutorial question. Okay, so our tutorial question. All right. Uh, we are going to discuss some of the application. All right, question. As I send the list of names, which I assign certain question to some people. All right. The list actually consists of all questions, but I don't think that this Wednesday we are able to discuss all. Okay, because we have actually so many questions. Okay, but what I'm planning to do this Wednesday, at least we will try to actually discuss some or maybe half, if possible, half of the questions. Okay, so that the rest maybe we can actually discuss next week. Okay, because you have to actually start also doing a tutorial question for your complex numbers. Okay, because we have already started complex number last week. Okay, so you still need to keep up with all the tutorial questions for complex numbers. Okay, because we just have another one more month to go. Okay, so it's not that long actually. Okay. All right. Okay. So as far as today is concerned, we are going to continue. All right. Talking about, or I am going to talk about complex numbers. All right. And perhaps let me just share my screen. Oh, before I forget also, just to inform you that I have uploaded, since actually last week, I've uploaded certain videos, okay, teaching videos in ULearn, okay, in ULearn. I think last week I uploaded also one based on one of the lectures. Basically, I'm teaching two groups, as you all know that I'm teaching your group, okay, BEE as well as one BEET. Okay, so I have the session for BET on Tuesday. Okay, as well as I have tutorial with them on Thursday. So I have a class with you today, Monday, as well as a tutorial on Wednesday. Okay, so basically, I would say that most of the stuff I'll be like repeating when it comes to VET session. I'll be like repeating, all right, repeating the lecture, or perhaps discussing tutorial question. Okay, so normally what I'll do is if I remember to record the session, then I will actually record it, and then I will actually look at which session that I don't have like so much problem. Okay, in terms of like remember last week we have like some issues, okay, technical issues, okay, with our Webex. Actually last week what happened was I was informed that it was an internet connection, okay, in UTEM. There was some problem, okay, at certain period. That's why we were having like some hiccups, okay, last week. Okay, so what I did is I went through the video, all right, the one that I recorded. So certain videos that which I think that it's perhaps can be benefited to you, I uploaded. So I've actually uploaded since last week. Okay, I think one video on the during the lecture session, and I think week nine. Okay, I uploaded one, and then under week 10. Okay, also, I uploaded one teaching lecture video session. Okay, during the video session for lecture, and then also I uploaded another. I think on during tutorial session. Okay, one of the session. Okay, so perhaps if for those who would like to watch it. Okay, so all right, I hope it will benefit to you. Okay, especially for those who also have like some problem with the connection, okay, internet connection at their hometown. Okay, so just to inform you that. Okay, all right. Okay, so we are still in complex number. All right, and perhaps what I can do today is to, before we look at some other stuff, or new stuff, okay, maybe I can just recap. Okay, so perhaps we can just recap whatever that we have learned last week on complex number. Okay, we started with what do we mean by complex number in terms of what is actually how complex number came about. Okay, from actually a mathematician invented, okay, complex number due to the reason where um, we cannot actually solve certain equations whereby we have a solution is actually involved with a square root of a negative number. Okay, so in that case, mathematician came out, or they invented what they call complex number. Okay, which consists of real numbers and imaginary numbers. Okay, and for that complex number I, we introduce the I takes the form of square root of -1. Okay, square root of -1, and this is what we call the standard form. Okay, the standard form of a complex number, all right, consists of what we call real part and imaginary part. Okay, a plus bi, that is what we call a standard form of a complex number. Okay, and I have shown you also like some examples of what we call a complex number. Okay, so and then we also talk about some of the properties, okay, on complex number. And we said that complex number, we can actually do arithmetic operation. Okay, we can add, subtract, multiply, as well as divide. Okay, and we said that for arithmetic like sum and difference, okay, when you add or subtract any complex number, basically what we'll do is we add or subtract real part with the real part, okay, imaginary part with the imaginary part. So we don't actually mix up. Okay, in terms of multiplication, however, in terms of multiplication, we need to expand. Okay, if we multiply two complex number, what we'll do is we expand. All right, we multiply one by one. So that's how we do product, okay, of two complex numbers. And along the way, we also talk about certain things on what we call the power of I. Okay, because there are cases where you might want to be able to actually compute, okay, or question may ask you to like evaluate, okay, certain powers of I. Okay, so again, basically always remember that I takes a value of square root of -1, and that I squared is -1. Okay, so basically actually enough for you to actually remember this. Okay, All right, and then we also talk about conjugate of complex number. Okay, conjugate of complex number. What do we mean by conjugate? So basically the difference, all right, between a complex number and its conjugate is actually the sign. Okay, sign plus minus in the middle. Okay, between the real part and the imaginary part. And basically the sign is actually is the sign for imaginary part. Okay, it's the sign for imaginary part. Okay, sign for real part stays as it is. So if you look at like this one, this is the complex number, this is the conjugate pairs. Okay, the conjugate of the complex number. So the sign that changes is actually basically is this sign of the imaginary part. Okay, imaginary part. So that is actually is the difference between complex number and its conjugate. And then you have also a theorem which says about a product of two conjugate pairs. Okay, so a product of two conjugate pairs where you have actually the product is actually is what we call a non-negative real number or positive number. So that is actually is a product of conjugate of complex numbers. You have a formula a squared plus b squared. All right. Okay, then only we talk about a quotient. Okay, a quotient. All right. We talk about reciprocal first last week because basically from a reciprocal expression or quotient expression, all right, when question asks you to write in the form of a plus bi, what you need to do is to multiply by conjugate. Okay, conjugate of the denominator for both numerator and denominator. Okay, then only we talk about division. Okay, division of complex number, two complex number. Okay, so this is division of two complex number. All right, again, to divide two complex number, what we need to do is to multiply by conjugate of the denominator for both numerator as well as denominator. And of course, numerator you got to expand because numerator then becomes like a product of two complex numbers. So you got to expand one by one. Denominator also is the same thing also. Actually, it's a product. It's a product of two complex number. However, because they are conjugate pairs. So when they are conjugate pairs, we have actually formula that we can apply. Okay, which is a squared plus b squared. But if let's say you forgot about this theorem, a squared plus b squared, what you need to do, you just need to expand. Just expand because basically these are product. Okay, and then this is how you write in the form of a plus bi, or what we call the standard form of a complex number. Okay, all right. Okay, basically there's also properties here. If you can see, okay, these are just some properties, okay, on the complex number. All right, remember the notation bar, z bar like this. Okay, what you have here is actually is z bar and then bar again. Okay, equals to z. Okay, so this is just a property of complex number. Okay, remember z bar is conjugate. All right, so basically this part again, if you want to make sense of all these properties, you can just come up with any example. For example, like if I'm talking about something like this, okay, property said that z bar and then bar again equals to z. What it means that if let's say we let z equals to just a simple, okay, just a simple 2 plus 3i. So what is z bar? Z bar is, remember, the difference is just negative, all right, for the imaginary part. And then if that this z bar, you bar it again, okay, then of course, all right, you are looking at here, so it becomes 2 plus 3i, and this is actually is the same as this, which is that's when, all right, you have these properties. Okay, that z bar, and then you take another bar again equals to z. This is what it means. Okay, and then you also have this property which says that, all right, conjugate of a sum, all right, conjugate of a sum of two complex number equals to, all right, sum of two conjugates of complex number. This is what it means. Okay, so similar to the product as well. So if you want to make sense of these two properties, you just come up with one example and then you will see that left hand side equal right hand side. Okay, any questions so far? Any questions so far? Okay, what I would like to do today for a start, okay, I'm going to just give like perhaps one questions where I want you to actually try. Okay, try this. Okay, I want you all to try this. If z1, this is z1 equals to minus 2 plus 3i, and another complex number which is 1 minus 4i, right, given, then find, okay, and then b, c, and then d. All right, can you all, I give you all like maybe a few minutes, can you all try this and then we'll see the answer. Okay, so everyone please try this. Maybe I'll give you like perhaps 5 minutes to try this.
Madam.
Okay, all right, so try this, try now.
பிரியா மேஜ்ல கால்குலேட்டர் இருக்கிற காணோம் தெரியுமா?
Nagawali.
இருக்கு. ஐயோ.
Okay, it's okay, Nagawali. Okay, I hope everyone is doing,
Madam.
Okay, you done?
Yeah, but not sure correct or not lah.
Okay, never mind. I'll give it another like 1 or 2 minutes for this. All right. Is everyone finished doing?
Baru sampai C, Madam.
Oh, baru see. Okay. All right. Okay. I'll give you another few minutes. Okay, maybe another 2 more minutes.
Sure, madam, sure.
Okay. Okay, all right. Can we look at the answer?
Madam.
Anybody? Okay, anybody would like to volunteer for A? What's the answer for A?
Negative 5i.
Negative 5i. All right, okay. Thank you, Yikin. Anybody got any different answer? Everybody got the same one? The same answer?
Yes, madam. 5i, negative 5i.
Okay, negative 5i. Okay, all right. So that's the answer, negative 5i. So if anybody got questions, all right, please just ask. Let me know. You can just disturb. If you don't have any question, that means I assume everybody got the same thing. Okay, what about B? Any
4
volunteers?
minus 2i.
Okay, Shami, 4 minus 2i.
2i.
Okay,
Yes, madam.
everybody got the same answer? Anybody
Same
got
answer.
different answer? Same answer. All right. Anybody got differently? Different answer. Okay, so this is the correct answer for B. This is a subtraction. Okay, what about C? What's the answer for C?
10 plus 11i.
10 plus
Okay.
11i.
All right, 10 plus 11i. I hope everybody got this one. Okay, so this is the correct answer for the product. Okay, any question? All right, no? Okay, then what about the last one?
10 plus
The,
11i over 17.
say again?
10 plus 11i over 17.
Okay, now if you write in the standard form, you should write in the form of, just now you mentioned 10 plus 11i over 17. Did you say that, Ikin?
Yes, madam. Yes.
So that means 10 over 17 plus 11 over
Over
17i.
17i. Yeah.
Okay. Anybody got any different answer for quotient or division?
Negative 14 over 17
Negative
minus
14 minus
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 5 over 17i.
minus 5 over 17i. All right. Okay. Any other different answer from anyone?
Idea. I mistake.
Okay. All right. Okay. So this is actually is the correct answer. This one. It should be negative 14 over 17 minus 5 over 17i. Okay. You double check this one
Mistake already.
Okay. All right. So double check that one. Okay, so the answer for the division of the two complex number would be minus 14 over 17 minus 5 over 17i. All right. Okay, so I hope everybody understood about this operation of complex number. Basically, addition, subtraction, multiplication, and division. Okay, and I hope that everybody already like familiar with complex number now. Okay, at least the basic of complex number, the basic part. Okay, so now let's us move to the next one. Okay, so the next lesson is we are going to introduce you with what we call polar coordinates. Okay, polar coordinates. I'm not so sure how many of you are familiar with polar coordinates or how many of you have actually encountered this before. All right, polar coordinates, or perhaps you may have encountered, but perhaps you have forgotten. Okay, because basically polar coordinates is not really that famous. Okay, the one that we are very familiar in terms of coordinate system is the rectangular. Okay, rectangular coordinate system. Okay, or Cartesian coordinate system. That is our XY coordinate system. Okay, so our XY coordinate system, okay, is what we call rectangular. This is our XY, all right, XY plane, or we call it XY coordinate system. Okay, coordinate system. Or we say Cartesian. This is another name, Cartesian. Cartesian coordinate system. Cartesian is after a name of a mathematician. Okay, Cartesian. So Cartesian coordinate system or XY coordinate system or our XY plane or rectangular coordinate. We call it rectangular coordinate system. It is our XY, okay, where you have your axis X and Y axis. Okay, so that is, I think, the coordinate system that you've learned since school. Okay, maybe what, primary school? I can't remember. When did we start learning about coordinate system? Maybe somewhere in maybe in primary school or maybe secondary school. Okay, so that is our what we call rectangular coordinate system. Okay, so now we have actually another coordinate system, which is what we call polar coordinate system. Okay, in fact, we have another coordinate system also. We call it spherical coordinate system. But polar coordinate is also another sort of like a famous also. Okay, it's just that perhaps it's not really that familiar. Okay, polar coordinates, all right, is actually the coordinate system itself is actually in like a circle. Okay, maybe if I can just show you. This is what we call, this is actually is the polar coordinate system. The look looks like this, or this is the grid, polar grid. We call it polar grid, okay. Rectangular grid is where your XY plane, okay, X axis, Y axis, okay. So if you remember not remember, I'm sure you know this. If you talk about Cartesian grid or XY grid, this is where you're like this, right? XY. And then you remember maybe during school days you used to use graph paper, right? Graph paper. Graph paper, right? You have all like that, isn't it? Graph paper like this. That's why they call it rectangular. Okay? It's like a rectangular shape. Okay? It's like a rectangular shape. Rectangular. This is like one rectangular. So that's why they call it rectangular shape or rectangular coordinate system. And the grid is something like that, like the one that you use your graph paper previously, right? So that is rectangular grid. So polar grid is something like this. Okay, it's something like this, polar grid. So polar grid, all right, the center here, the center in the middle is what we call pole. Okay, the middle, center in the middle is what we call pole. If our rectangular grid, okay, rectangular coordinate system, the center, we call it origin. Okay, we call it origin. But for polar grid, the center in the middle here, point in the middle, we call it pole, P-O-L-E. Okay, it's a pole. Okay, and then this, what we call like our positive our positive x-axis in our rectangular coordinate. For polar, we call it polar axis. Okay, we call it polar axis. Okay, so polar axis in our polar grid, in our rectangular grid, we call it positive x-axis. Okay, and if you look at this polar grid, okay, it consists of what? Okay, you have actually consists of two things here. If you see all this circle, okay, this circle, and then you have this circle, you have this circle, all right, this circle. So the circle, actually, it doesn't stop until here. It can goes on and on. It can be like a big circle. Now that circle represent what? Represent distance. Represent a distance from the pole. Okay. Perhaps like the one here starts from the pole. Pole means that no distance. Distance is 0. Okay. Maybe this is actually a distance of 1 unit. 1 unit distance. 2 unit distance. Okay. 3 unit distance from the pole. 4 unit distance from the pole, 5 unit distance from the pole. So imagine if you're talking about 10 unit distance from the pole, you will have like a 10 circle. Okay, so basically the circle represent distance from the pole. So on polar grid, so that means we can actually write a number, a distance number on our polar axis. We can say that circle 1 here is represented by 1 unit. This is 2 unit. This is 3 unit, 4 unit, 5 unit, and so on. Okay. So you have a circle represent distance from the pole. And then if you notice, you have all this. You have angle, isn't it? These are all angle. So what you have actually is like a one complete revolution. Okay, one complete revolution. So polar axis is your 0 degrees or 0 radian. Okay, 0 degrees or 0 radian. So you go like one complete revolution until your 360 degrees. Okay, 360 degrees. So basically you have learned this, all this angle when you did your trigonometry in chapter 2. Okay, so you have like this is polar axis actually represent 0 degrees or 360 degrees. Okay, 0 degrees or 360 degrees. That is your polar axis. Okay, 0 radian or 2 pi radian. So if that's in radian, okay, and of course you have all this. Okay, you have pi over 12, pi over 6, pi over 4. Basically, you understand this pi over 6 is 30 degrees, pi over 4 is 45 degrees, pi over 3 is 60 degrees, pi over 2 is your 90 degrees. Okay, so you have your 180, you have your 270 degrees, okay, and back to 360. So that means polar coordinates, okay, consists of, back to here, okay, so if you look at the table that I have here, okay, I'm writing in terms of what we call the difference. What's the difference between your rectangular and your polar coordinate system? Okay, so if you look at the center, all right, rectangular is the origin. Okay, polar, we call it pole. Okay, the positive horizontal line. If rectangular, we call it positive x-axis. Polar, we call it polar axis. Okay, for polar coordinate. Now, in terms of coordinate pairs, okay, coordinate for rectangular, we have this representation, xy. So in the form of xy coordinate, we call it. However, pole, so this is the one where you have in the form of what we call r theta. So what is r? What is theta? So basically, all right, r stands for the distance. All right, distance from pole. All right, that is r, distance from the pole. Just now, remember, circle, you have your starting from the middle, and then you have like circle, one circle, okay, like this one just now. Okay, so this, the first circle here maybe is in terms of distance of 1 unit from the pole, and then the next circle is 2 unit distance from the pole. All right, this is the 3 unit distance from the pole. Okay, all right, so R stands for distance from the pole. Okay, whereas theta, okay, theta is, of course, theta is what? Is the angle. Okay, so theta is the angle formed between the polar axis and the ray from the pole. That is theta. So theta actually represent the distance, represent the angle formed between the polar axis and the ray from the pole. Okay, that means what is the ray? Ray is this one. This is what we call, all right, this is what we call ray. Okay, this is a ray. So from polar axis to this one, this ray, this is pi over 4 unit, right? Angle is formed, pi over 4 is formed by polar axis and this ray. So that is pi over 4. Okay, so angle between polar axis to this ray here is pi over 2. Okay, all right, so that is what we call theta. So basically, all right, the coordinates for polar, all right, polar coordinate is in the form of r theta. Rectangular is in the form of x, y. Okay, polar coordinate is in the form of r theta. Okay, there is another one major difference, okay, between rectangular and polar coordinate. There's one major, all right, difference in terms of its coordinate, okay, coordinate number. Now, if you're talking about rectangular, okay, when you say you have a coordinate of -2, 3, you have something like this, which means the location for this -2, 3 is actually is just one location. Okay, it's one location only. That means if you were to plot, okay, if you were to plot your -2, 3, how do you plot? Okay, if I'm looking at the grid here, all right, of course, if you can see, all right, if you can see something like, we say that this the middle here is the origin. This is 0. Okay, this is 0, this is 1, 2, 3, this is -1, -2, -3. So going up for y is 1, 2, 3, going down -1, -2, -3, right, last time. So when we say -2, 3, it is understood, okay, from the graph, -2, 3, you are going to locate your coordinate at this point here. That is the point of -2, 3, right? That is the point. That means, all right, from the origin, from the center, from the origin, so -2 means you go to the negative direction of your x-axis, 2 units, 1, 2. And then 3 means positive, you go to the positive direction of your y, 1, 2, 3. So this is the only location which has this coordinate of -2, 3. Okay, all right, so it means that the coordinate is unique. Okay, is unique, it's very unique. That is the only place or location, all right, which has this address in a way, right? -2, 3. So there's no other location, or at that particular location there is no other coordinate. Okay, the coordinate for that particular location is -2, 3. That is rectangular. Whereas if you talk about polar coordinate, let's say I say you have a coordinate of 2 and then 45 degrees. That's how we write. Or if it is in radian, it can be written as 2 pi over 4. So angle, all right, angle can be in radian or it can be in degrees. Okay, angle can be in degrees or it can be in radian. All right, so let's say we say 245 degrees or 2 pi over 4. How do you plot? Okay, if it is on polar grid, okay, if it is on polar grid, perhaps it's easy because whenever you have a grid, okay, that means how do you plot 245 degrees or 2 pi over 4? From the grid, it's easy to see. Basically, all right, it is on the second circle, right? Second circle is your 2 unit distance from the pole. So you just need to find out where is pi over 4 ray. The ray for pi over 4 is here. So that means that is the location. The location would be this point here. That is the location for 2 pi over 4, or you can say 245 degrees. That is the location. That's the plot, okay, of that coordinate of 2 pi over 4. All right. Okay, I hope you can follow me. How do I plot this? Or if let's say, what is this location? What is this location represent from the grid? From the grid, maybe it's easy to see. What is the What is the coordinate for that particular location? Okay, you just need to find out. That is how many distance, all right? How many unit distance from the pole? So basically, you have from the pole 1, 2, 3, 4. Okay, so that is on the fourth circle, 4 unit. Okay, 4 unit distance. And in terms of angle, is 5 pi over 12 is given from the grid. So that means that is 4. You can write it as in terms of 4 and then 5 pi over 12. Okay, or maybe this circle, this point, this location there, that one. Okay, this is the location of 3 pi over 2. Okay, now if we ask you to plot without the grid, how do you plot? Okay, how do you plot polar without the grid? Okay, for example, like this one, 245 degrees. How do you plot without the grid? Of course, you will not be given polar grid. Okay, if question asks you to plot, you just plot roughly on your paper. How do you do that? Okay, the way you do it, okay, if we were to ask you to plot, for example, plot this 245 degrees here, okay, or 2 pi over 4, what you need to do, this is just a rough sketch. You start from the pole, okay, and then draw your polar axis. Okay, so this is pole, this is polar axis. Starts from the pole and then polar axis, and then you just roughly measure 45 degrees. Okay, that is 45 degrees. Okay, that is 45 degrees. All right, and then you just need to roughly like measure 2 units, okay, from the pole. So which means, okay, just a rough only. Let's say this is the pole. From the pole, let's say 1, 2. Okay, and then so this is 245 degrees. That's the location. So this is just a rough sketch. Okay, or let's say we ask you to sketch, for example. All right, let's say we ask you to sketch or plot 3 and then pi over 2 just now. Okay, plot 3 pi over 2. So what you need to do, okay, so you just need to draw like from the pole, okay, and then draw your polar axis, and then just draw your pi over 2. This is your pi over 2 or 90 degrees. So then just roughly, all right, locate your, let's say this is 1, 2, 3. So that is, you can say 3 pi over 2. So it's only a rough sketch only, okay, for plotting polar coordinates. But that's how you sketch, okay, on your paper, okay, without polar grid. Okay, next question is, just now I mentioned about a big difference, right? So a big difference is actually is about the coordinate, the location of the coordinate, okay, coordinate point for polar. Now, if I show you again this polar grid, okay, if you look at, let's say we look at this location here, pi over 2 pi over 4 again, right? 2 pi over 4 again, or 245 degrees, okay, 245 degrees. Okay, do you think that that location has this only one coordinate or one polar coordinate here? This location here, 2 pi over 4, is that the only coordinate for that particular location in polar grid? What do you think? Okay, what do you think?
Not sure, madam.
Perhaps not sure. Have you learned about this before, Shami? Polar.
Yeah, but
Polar.
karat already.
Okay, forgotten already, isn't it? Okay. All right. Okay, remember when we talk about angle, okay, angle in angle with, of course, angle goes like this, right? Well, complete one complete revolution, 360. And angle actually can goes on and on in terms of revolution. Okay, it can go like one revolution, 360. So it can go second revolution, third revolution. It can keep on going like that in circle, isn't it? Okay, angle. So that means this particular location here, where you have your 2 pi over 4, all right, this is not the only coordinate, okay, that represent this location on the polar grid. One coordinate, yes, 2 pi over 4, 245 degrees. If I go another one complete revolution, that means 45 degrees plus 360. So that would be what? 405, isn't it? So that means another coordinate can be written as also 2 pi over 4 plus 2 pi. Or if let's say in terms of degrees, in terms of degree, 360 degrees plus 45 degrees. That is your 405 degrees. So it is actually that particular location as well. That is if I go just one complete revolution. Okay, I just go one complete revolution. If I go twice, so that means, this is one complete revolution, 405. If I go another round, I come up to the same location also. I can land it at the same location. What if I go third round, fourth round? This one, I'm going counterclockwise. Okay, counterclockwise direction. Okay, counterclockwise direction. What if I go clockwise direction? I can go like that. With a negative angle, I can go like that. Okay, I can go in terms of negative angle. So that means for polar grid or polar coordinates, one location here can be represented by infinitely many coordinates. It can be represented by infinitely many coordinates. That is a big difference between polar coordinates and rectangular coordinate. Rectangular, if you say just now, -2, -2, 3. Location is only one location only. There's no other location, or there's no other coordinate that represented by that particular location. Okay, all right. However, if it's a polar, all right, it can be represented by many or infinitely many coordinates for one particular location. Okay, so if let's say I ask you to plot for example, 2405 degrees. You are going to give me same plot as this. Because you know why? Because let's say you want to plot 2405, how do? You start with the pole, draw your polar axis. Okay, pole and polar axis. What you need to compute? All right. One circle, one round is 360 degrees plus with another 45 degrees. So then you have your actually this is 45 degrees. Okay, that is this much is actually 45 degrees. Okay, that is 45 degree. But you go one circle, one rotation already. You go one complete revolution plus with another 45 degrees. So that is actually your 405. And then again, you just need to measure 2 unit distance from the pole. So let's say 1, 2. So that is your 405 degrees. So which means this one and this one is actually it's the same thing. It's the same thing. Okay, it's the same location. All right, it's the same location. Okay, so this is where I just mentioned about r, which is a distance. Okay, distance from the pole, that is r. This r is in the form of a positive r, positive distance. What if it's a negative? Okay, negative distance, negative r. All right, negative r. What about negative r? Okay, so if I look at again my pole, okay, this particular again 2 pi over 4, this particular location also can also be represented by another coordinate which actually with a negative r. Okay, with negative r. So negative r is where? That means if I look at the grid, look, if we are given a grid, it's very easy. This is pi over 4. So it's just that, okay, if I go like straight line here, that means I'm looking at this 5 pi over 4. Okay, so that means from the pole, my angle is at 5 pi over 4. So it can be like 1, 2, and then negative means you go to the opposite like that. So which means that coordinate, this 2 pi over 4, in terms of the negative r, it can be written as negative 2 and then 5 pi over 4. That is in terms of, it comes to the same location here. Okay, for the coordinate minus 2, 5 pi over 4, that minus 2 is the negative r. Okay, negative r is negative, minus 2. So minus 2, 5 pi over 4 is actually is here. Okay, it's actually is there. All right. Okay, now 5 pi, okay, over 4 is what? 5 pi over 4 is actually is 225, right? 5 pi over 4 here is actually is 225 degrees. Okay, which means, all right, if we say that plot negative 2 to 5 degrees, plot this. How do we plot this? It's always from the pole, starts from the pole, polar axis. Okay, from pole, polar axis. What you need to do, we need to actually draw angle first. Identify the angle. So that means 2 to 5 is somewhere like in the third quadrant. That is our 2 to 5. Okay. And then what you need to do, because of your r is negative. Okay, r is negative. Okay. So we will go like to the opposite. It will be like, you just need to like extend. Okay, extend your line here. Okay, It's a straight line. You go to the opposite of that 2 to 5. Then you measure from the pole 1, 2. So that is location of -2, 2 to 5, in which this angle here is actually 45 degrees angle. The angle is 45 degrees angle. So which means this, and this are all the same location. Same location. So this is actually is a big difference between polar coordinates as well as rectangular coordinates. Okay. However, this is just for your knowledge. Okay. I think we are not really ask you so much on plotting polar coordinates, because this is just an introduction about polar coordinates, because we are going to look at complex number in polar coordinates. Okay, because we need to, after this, extend one more knowledge. We are talking about now, later on, is a now complex number in polar coordinates. So basically, when we talk about polar coordinates, we cannot run away from angle. Okay, from angle. All right. So when we talk about polar coordinates, you know that you will deal with angle. Okay, so again, the understanding of the angle is from your chapter, from chapter 2. Okay, so from chapter 2. So this is what I'm showing you here is only just introduction about what do we mean by polar coordinates. Because then after this, all right, we are going to extend one more knowledge in terms of our complex number in polar coordinates. And between rectangular and polar, because this is, we can see some differences and some similarities. Okay, you will see some similarities and some differences, and we are going to, after this, like sort of like map our polar onto our rectangular, and then you will see that, you know, because of there are some similarities, all right, we can sort of like convert. Okay, we can find relationship between rectangular and polar, so we will actually try to find out some conversion formulas, as in like to convert from rectangular to polar and then convert back from polar to rectangular, so based on some similarities that we can actually see afterwards. Okay, all right, so perhaps it's already like 11 o'clock, so take a 5 minutes break. Okay, 5 minute break, and then after that we will continue. Okay, but before that, any question? Can you all understand? Can you all follow? Can you all follow?
Ma'am,
Yes. Yes,
sorry,
Sadat.
I need to ask one
Yeah,
question.
sure, sure.
Okay, for example,
Many questions is
just
okay.
now
No
Puan
problem.
say, okay. Puan said the R is the negative 2 means
Ah,
it could be 5, right?
mm.
It could be 2 to 5. How about if the O is a negative?
Oh, you mean angle?
Yeah,
Negative angle. So if let's say,
yeah,
okay, you just give me one coordinate.
45 maybe.
Okay. What's the R? You want to see what's the R?
Maybe negative 2.
Okay, so negative 2, negative 45 degrees. How do we plot this? Right? Okay, how do we plot this? Negative 2, negative 45. Okay, this one will be a bit different. Okay, this one will be a bit different because angle is negative 45. Okay, but how do we plot this? Okay, you will see. Okay, always starts from the pole. Okay, and then draw your polar axis. Draw your polar axis. Okay, identify angle first. Okay, we must identify angle first. We must measure angle first. So assuming that, okay, negative 45 means you go clockwise direction. So that means you go this way. That is going towards negative angle. So assuming this is negative 45 degrees. Okay, and then only you see your R. What is R? Because R is negative 2, so you got to some sort like extend your line this way, which is actually is a straight line. This This is a straight line. Okay, it's just that my straight line normally is not straight. So you go like this. Okay, then only you measure 2 unit distance from the pole. So this is pole 1, 2. So that means this is the coordinate for -2, -45 degrees. So that's the coordinate. -2, -45 is this coordinate. That's the coordinate. That's the location. So this -2, -45, it is not the same. It's not the same location as this one. Not the same location as this one. Not the same location as this one. Okay. -2, -45, the location is there. But if you want to find other coordinate that has the same location here, what you need to do? Okay, of course, you just need to find in terms of positive angle. Positive angle, this angle is how much? That is actually what? 125, isn't it? 135, right? Okay, because it's 90 degrees plus 45, isn't it? Oh, sorry, 180 minus 45. So that is that correct? Okay, so that is 180 because you are using your what we call the reference angle. So you just need to subtract 180, you minus with 45, so you get your 135. So this is 135 degrees. So in terms of another location, another coordinate that has the same location, it will be, if I'm using positive angle, that means my R is actually, in this case, is also positive. So 2, 135. This is another coordinate which is similar to -2, -45 degree, which has the same location. Okay, so that's how we actually plot for -2, -45.
Okay.
Okay, all right.
Okay.
So if you want this, if you want the same location here, which has negative angle, okay, which landed to the same location here. All right, what you need to do, actually, you are going this way from again, this is polar axis. All right, you just need to find out what is your angle here in terms of negative. Okay, so that means you are going this way, in terms of from here to here. Then that is a negative angle. So how much is that? How much is that? Negative what? Negative 315, isn't it? That's the angle. Because that
Yeah.
location, negative 315. So that means another coordinate would be 2, all right, negative 315 degrees. Because I'm going that way in terms of negative, all right, and then I just measure 2 units from the pole. 1, 2. So this is actually is a coordinate, all right, which has this negative angle, all right, negative angle, but at the same location as -2225 or 2405 or 245. So actually that particular location has actually infinitely many coordinates. That is actually polar coordinate. So that's why sometimes polar coordinate can be rather confusing. Okay, because that one particular location can be represented by infinitely many coordinates. So not just one coordinate, not like our rectangular. Our rectangular, if I say coordinate of 0, 1 or 5, 3, you only have one location that is represented by that particular coordinate number, but not polar. Polar coordinate, one location can be represented by infinitely many coordinates. Okay, so it can be rather confusing because you need to know, all right, how to see. Okay, how, and in fact, if it's plotting, is not difficult. Okay, it's not difficult because you just need to know how do you plot. How to plot is you go by the coordinate, the angle first, then only you identify the R. Okay, but if let's say we just ask you something like we talk about coordinates, so sometimes it can be rather confusing because your mind need to figure out, you know, the location for that particular coordinate. Okay, but this is only for your information. Okay, this is for your knowledge. Okay, I do not know whether the question may ask you to plot or not. Okay, but if there's a question asking you to plot, okay, because I haven't checked the book, but if there's a question asking you to plot, I suppose they just ask you to plot just a simple coordinate only. Okay, a simple coordinate. Okay, all right. But this is how we plot our r theta. Okay, our r theta in our polar grid. Okay, or polar coordinate system. Okay,
Swan,
Sarah.
if
Yeah.
let's say the is a positive mean, it could be downside, right? The downside,
Yeah, it can be, but depends on what angle. Always like this.
like
How do we
240, negative 45. The same
if
thing. So 2 negative
okay, if you
45, it
say
could be the 2B.
say again, if it is 245.
Yeah, 245.
Okay, 245 is this one,
No,
right?
no, no. 2 negative 45.
Oh, 2 negative 45. If you say 2 negative
Ah,
45 is here. This is the one. This is your negative 45 here, right?
yeah.
This is negative 45. Okay, 2
And the
negative
2 is
40.
down there.
Yes, correct. So that
Okay.
means from the pole 1, 2. So this is the coordinate of 2 negative 45 degrees. Yes,
Okay.
that's the one. Okay.
Okay.
So if let's say you find out the angle first, and then your measure r, your distance from the pole going towards to that particular angle, that is positive r. Okay. So negative r means you go to the opposite like that. Okay. So if it is just now 2 minus 45 is here. Okay. But the moment we say negative 2, negative 45 is the opposite. It's the opposite. Like that.
Okay, one.
Okay.
Okay, one.
All right.
Okay, thank you.
Okay. All right. Okay. We'll take a break for a few minutes. Okay, can we now continue?
Madam.
All right, can we continue? Can?
Madam.
All right. Okay. Next one is about relations. Okay, again, as I said, because there's a similarity between polar and rectangular, so we can actually map, sort of like we map our polar and coordinate, rectangular coordinate on the same axis. Because if we look at just now I mentioned, you have, for example, in rectangular coordinates, the middle here is what we call center origin. Going this way is our positive x-axis. Okay, so in our polar, okay, our polar coordinate, the middle here, okay, this is origin for rectangular, whereas for our polar, this is what we call the pole. Okay, and then going this way we say polar axis. So now you map these two. Okay, so you map these two. Okay, so if you map these two, maybe I can just draw this. Okay, so this is our point there. This is the origin, as well as this also can be said as a pole, isn't it? Okay. All right. So this is our x-axis, or it can also be look at it as like polar axis. Okay. So that straight line there, horizontal straight line. Okay. Now, if I say xy coordinate, let's say we talk about like 1 point. In terms of rectangular, we say xy coordinate. It will be represented by xy coordinate. What do we mean by this xy coordinate, that location? That means, okay, remember, you can actually, this point here, that means you go like x unit distance, all right? And you go by y unit distance, isn't it? Y unit distance. Okay? So I can actually draw some sort like one rectangle shape. It's a right angle triangle basically, isn't it? Okay, for my xy. And if I'm talking about this coordinate here, the xy coordinate here, in terms of polar coordinates, this also can be represented by in the form of r theta. And what is r? R is here. R is a distance from the pole. Okay, r is a distance from the pole to that particular point or that particular coordinate, isn't it? That is our r. And this is our angle theta, isn't it? Okay, so from this diagram then, you can actually come up with what we call the conversion formula, or we can come up with what we call a relationship. Okay, a relationship, okay, between polar and rectangular coordinate system. Okay, we can come up with a relationship between our rectangular coordinate system and polar coordinate system, and that relationship will act as what we call a conversion formula. Okay, now we can define our x, okay, XY are rectangular coordinate. R theta is polar coordinate. Now, we can define our X here in terms of R theta. Okay, we can define our X here in terms of R theta. That means, if you don't see your, ignore the Y unit here. Okay, ignore this one. That means you just look at X. This is X. All right, and then you look at R and theta. Okay, ignore the Y, but of course you have this rectangular shape, a right angle triangle here. So if you want to define a relationship between X, this line, this angle, and this R, isn't that this is what we call our adjacent, right? This is adjacent, right? In trigonometry, adjacent. This is our hypotenuse. Okay, this is our angle here. All right. So isn't that we can define in terms of our trigonometric ratio between X, R, and theta? That is what? That is what? What is adjacent over hypotenuse? Adjacent over hypotenuse is our cosine, right? Cosine theta. So that means cosine theta, okay? Cosine theta equals to X over R. Okay, cosine theta equals to X over R. So X equal to R cos theta. Okay, X equal R cos theta. Similarly, if let's say now you look at a relationship between Y, R, okay, and theta. Okay, so this is theta. Again, this is your hypotenuse. Now this is our opposite. So remember, opposite over hypotenuse is our sine. Okay, our sine. So that means our sine theta from the diagram equals to Y over R. So isn't that we can write Y in terms of R sine theta? So basically you have this, all right, you have this some sort like what we call like a conversion formula or relationship. Okay, okay, you can define your rectangular in terms of polar. Okay, rectangular is X and Y. That is rectangular coordinate. This is our polar coordinate. R and theta is our polar coordinate. So X equals to R cosine theta, Y equals to R sine theta. Okay, and we can also define a relationship, okay, between R, X, and Y. Okay, so ignore theta first. Ignore theta. Don't look at theta first. Just look at in terms of this right angle triangle. This is right angle triangle. Relationship between R, Y, and X, or X, Y, R. That means look at relationship between all the three lengths or three sides of your right angle triangle. So what is the relationship? So one relationship is the famous Pythagoras theorem, okay, which talk about all the three sides, the length of all the three sides of a right angle triangle. That we can say that R squared, remember, equals to X squared plus Y squared. That is from Pythagoras theorem. Okay, all right. So R squared can be written as X squared plus Y squared. This is from Pythagoras theorem for a right angle triangle. So we can define our R in terms of square root of X squared plus Y squared. Okay, and also if we want to find a relationship between angle and the length x and y, okay, angle and then x and y, okay, relationship between theta, x and y. So isn't that y over x equals to tangent theta? Tangent theta is opposite over adjacent. Opposite is y, adjacent is x. So tangent theta equals to y over x. So tangent theta equals to y over x. So then theta can be defined as tangent inverse of y over x. So you have then a relationship. Okay, so you have a relationship of this as well as this. Right? So which means if you are given in terms of rectangular coordinate, okay, you are given in terms of rectangular coordinate, that means x and y. X and y are given. Okay, rectangular coordinate is given, x and y are given. So you can actually find r and theta. So you can convert. If rectangular is given, you can find your polar coordinate based on the rectangular here, because then you can compute r as this square root of x squared plus y squared. Then you can compute for your theta angle as tangent inverse y over x. If, however, polar coordinate is given, polar coordinate means r and theta given, then you can find your rectangular in terms of x and y. So then if r and theta is given, you can compute x, because then x is r cosine theta, y equals r sine theta. That means all this, what we call conversion formula or relationship, the right hand side, or whatever the right hand side is, it must be given. Then only you can compute the left hand side. Okay? If you want to compute the left hand side, that means the right hand side is given. This is what it means. Okay? So if question asks you, find polar coordinates given rectangular coordinate, that means you are given x and y. That's why you can find polar coordinates, r and theta, or vice versa. So basically, this relationship, okay, you don't need to memorize if you actually understand this concept here, the diagram here, because all this relationship you can always identify from this diagram, because this diagram is not that difficult if you have understood what I explained just now. Okay, because it is actually it's a coordinate on the plane for both rectangular and polar, where you can actually map these two plane on the same scale. All right, and then you just need to look at that coordinate xy or r theta, and you have this concept of a right angle triangle here. So you can just find the relationship between r theta, x and y, because this is actually is very important relationship or very important formula. Okay, so this topic, all right, you will see that you will be actually using, all right, a lot of this calculation. Okay, you'll be using a lot of this calculation for the rest of chapter 4 after this. Okay, so in a way you must actually some sort like remember this by heart. Okay, if you can actually memorize this by heart, that is even better, because you will be like using a lot of this after this. But again, as I said, if you have forgotten this, you can always get it from this diagram here, because then this is actually logic. This is logic. Okay, all right, let's look at example. I have actually a few example on how do we actually change, okay, or convert, okay, from polar to rectangular, rectangular to polar. Okay, let's look at this example. So if anybody got any question, you just ask. Okay, let's look at this question. Let's look at this example. you are to find the rectangular coordinates of the points with the following polar coordinates. So this example, you are given in the form of polar coordinates, because when you look at the given coordinate, you are given in terms of 2 and then 3 pi over 2. So you have an angle there. Minus 8 pi over 3. So you have r and theta. You have r and theta. So it's understood. What is given here is actually is a polar coordinates. So from the question, they want you to actually find in terms of rectangular coordinates. So rectangular coordinates, all right, means the xy. Okay, it's the xy. Okay, so this is again the conversion formula that you want. You are given r and theta. From the question is given r and theta. So that means you want to find x and y now. Okay, so you have your x equals to r cos theta, y equals to r sin theta. So it's actually a straightforward conversion. Okay, let's do one by one. We do the a first. Okay, so let's say this is our a. Let me see. Do I have enough space? Okay, all right. So let's do a first. Okay, 2, 3 pi over 2. All right. Now, wherever you are given this question, okay, so it is actually it's good that you just need to just plot and then see. Just okay, this is actually is a good idea to see. All right, where actually this point lies in. So again, if let's say we plot, okay, let's say before I change this, I just want to plot. All right, plot this 2, 3 pi over 2. Just now we said that what we can do, okay, we can just it's a rough sketch. All right, 3 pi over 2 is how much? 3 pi over 2 is 270, isn't it? Okay, it's a 270 degrees, right? So that means let's say this is your pole, okay, polar axis. All right, just find out your 3 pi over 2. So again, as I said just now, 3 pi over 2 is 270 degrees. So that means it is actually just in a way it's a straight line going down. So this is your 3 pi over 2, isn't it? Your 270, or in other words 270 degrees. Okay, and then from the pole you just need to measure 2 unit distance. So from the pole, let's say assuming 1, 2. So you have that point here. This is your 2, 3 pi over 2. So when you plot, it gives you some sort like an idea, okay, about your rectangular coordinates, isn't it? Because if you map, all right, if you map this, all right, this one onto rectangular coordinate, isn't that this is origin? Okay, the pole is the origin. This is your positive x-axis. Okay, so what is this coordinate here logically? Anyone? Not to say some sort of like logic thinking. If you can sort of recall, if you map this on your rectangular grid, okay, this is your center pole, and then this is the point here, 2, 3 pi over 2. What do you think the coordinate for your rectangular coordinate without computing using formula yet? Because this can give you some sort like an idea, isn't it? What do you think? What is the coordinate here? This is actually is a straight line, isn't it? Straight line is a straight line going down. But if you like draw like one stretch straight line, right? That is what axis, y-axis, isn't it? It's a y-axis. This is x-axis. This is y-axis, isn't it? So this is origin. So you go down. From the origin 0, 0, you go down on the y-axis. So what is the coordinate here?
Negative 2, 0.
Negative 2, 0, isn't it? Right? Negative to
Okay.
0. If you're talking about xy, right? So this is origin, go down 2 units. So on the y-axis itself, isn't it? Okay, on the y-axis. Or is it 0, negative 2? The opposite. Because x is 0, isn't it? 0, going down, y is negative 2. 0, negative 2, Shami, is the opposite. Not
Okay,
negative
madam.
0.
Sorry, sorry.
Okay? Because x coordinate is 0, y coordinate is going down, negative 2. Right? So that's why, you know, when you plot, you have a rough idea. Okay? You have a rough idea. Okay, so let's compute this using formula. Okay? So when you compute using formula, this is your r. This is your theta. So r equals to, theta is 3 pi over 2. So by using the formula, x equals, you have a formula just now, x equals this one. Okay? This one. X equal r cosine theta. Y equals r sine theta. Okay? So x equal r cosine theta, which means 2 times cosine 3 pi over 2. Okay, you can just use formula, you can just use calculator to compute this. What is cosine 270? What is cosine 3 pi over 2? Cosine 3 pi over 2 is what? 0, isn't it? Okay, you can use your calculator. Alright. So you got your 0. Okay, I don't have calculator with me right now, but I remember the graph of cosine is something like this. 0, pi over 2, alright, pi, 3 pi over 2, 2 pi. So that's why here, alright, 3 pi over 2 is 0. So you got 0. Okay, alright. So that is x. And then you compute for your y using r sine theta. Again, r is 2, sine is again 3 pi over 2. Okay, so 2, okay, sine 3 pi over 2. Use your calculator. Alright, I don't have a calculator, but I remember sine shape is like this. Okay, so this is 0, pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. This is 1 and minus 1. So from the graph, I can tell that is minus 1. So that means minus 2. So therefore, you can conclude, alright, that the rectangular coordinate of, oops, okay, the rectangular coordinate of the given question just now is 2, 3 pi over 2 or 0 minus 2. Okay. Okay. So that is the first question. 2, 3 pi over 2. Okay, can you all try B? Can you all try B? See what you get? For minus 8 pi over 3. Can you all try that? Oh, that's a question. Madam, how to get minus 2? I hope you understood already here. Minus 2. Minus 2 here. You can use calculator for sine 3 pi over 2. You can use calculator because I don't have a calculator with me right now. So I can just look from the graph of sine. So 3 pi over 2 here is minus 1. So just substitute. So get minus 2. Okay, is that? Alright. Okay, sorry, there's a noise here. I hope you don't really hear the noise. There's a construction here. There's a construction next door. Can you all hear the noise?
Yes, clearly.
Yes, somebody is drilling something. Sorry about that.
Second,
There's a
second.
construction. There's a construction, beside. Actually, I'm at home. I'm working from home today for some reason. There's a renovation, next door neighbor. Sorry about that. Okay, try B and see what you get for rectangular coordinate for -8 pi over 3. You can just compute straight away, but it is good to actually plot so that you can see roughly where is the coordinates, all right, lies. Okay, are you all done for -8 pi over 3? Okay, anybody got the answer? What is the rectangular coordinate for -8 pi over 3? 0 minus 8. 0 minus 8. Do you mean 0 minus 8 for B? Don't think so. 0 minus 8. Yeah, it's wrong, Akmal. Correct. Okay. Try again.
But instead, the answer is -4, -7.
-4. What is the y
-7.
coordinate?
The y
Negative
coordinate is
7.
-7.
I don't think -7 because you are computing cosine and sine pi over 3. And then
Okay, okay.
try again, sorry. Try use calculator. Like x equals to -8 and then cosine pi over 3
Actually, I'm getting the decimal point, -6.9. Wrong, right?
or negative. Okay, -6. I don't have a calculator, so I do not know what's the decimal. But if you say -4, you said negative something, that is correct because if we look at the plot, it's actually is somewhere in third quadrant. Okay.
Okay.
Negative
Instead,
number is correct.
-6.9.
Okay, -6.9. Okay, I hope the rest can compute and get the same thing because I don't have calculator with me. Okay, but when I look at this, I know that coordinate has to be in the third quadrant. So when you say y coordinate just now -7 or -6, then it is correct. It's in the third quadrant. Okay, because if we plot, okay, as I mentioned just now, it's a good, good in a way. It's like it is advised to just plot rough sketch only, just so that you know logically later on what is your rectangular coordinate. So when we plot this, okay, remember it will be like from the pole. Okay, from the pole, this is polar axis. Okay, we find our pi over 3. Pi over 3 is our 60 degrees, right? So assuming this is our 60 degrees here, that is 60 degrees, pi over 3. So when we say -8, -8, so remember we go this way. We go to the opposite. So then from the pole, okay, from the pole, you compute like 8 unit distance. Okay, from the pole, all right. you go minus 8 unit. 1, 2, 3, 4, 5, 6, 7, 8. Assuming this is the one. Okay. So your point is here. All right. Okay. So your point is here. All right. So that means you are somewhere. If you draw your coordinate axis a rectangular, so that means it's in the third quadrant. So that means you are correct with the negative value just now. Okay. So the point here is oh sorry. So the coordinate is here, somewhere here. All right. So this is the coordinate of minus 8 pi over 3. Okay, which means that it's in the third quadrant. So if I straight away compute, as I mentioned just now, straight away compute x equals to r cosine theta. So this is your r. R is negative 8. Okay, this is r. This is theta. So r is negative 8 times cosine pi over 3. So negative 8 times, okay, what is cosine? Remember, cosine 60. What is cosine 60? Remember cosine 60? If you remember the triangle last time, okay, if you remember the triangle last time, the value, this is theta. So you have your 1, 2, 3. Oh, sorry, this is your 60 degrees. Sorry, this is 60 degrees. This type of rectangle angle. You can use calculator because I don't have a calculator. So I need something else to fall back. So 60 degrees, you have your 30 degrees. And then you have your 1, 2, 3. Okay, so cosine 60 degrees is our half. So isn't that this is negative 4? So that is our x. And then compute for the y, which is r sine theta. So again, minus 8 times sine pi over 3. Okay, so what is sine pi over 3? Okay, so sine pi over 3 is our third. From if I look at my triangle, third 3 over 2. Which is my minus 4 3. Okay, that's why I said I don't have a calculator, so I do not know what's the decimal here. You can compute. So you have negative, negative. This is what I'm saying. Okay, which means that is correct because looking at here also, that means this one is if you map on your xy axis, okay, so this is in the third quadrant. This is in the third quadrant. If we map on our xy axis, okay, our xy axis, this is in the third quadrant. So of course then our coordinate will be negative, negative, isn't it? Okay, so which means then therefore we can say that the rectangular coordinates of just now minus 8 pi over 3 are minus 4 sec 3. Okay, Saran? Okay, you can compute there minus 4 times sec 3. Do you get that minus 6 point something, right? Okay, all right. Okay, let's look at this question now. This is the other way around. Now you are given rectangular coordinate, but question asks you now to find polar coordinates. Okay, so rectangular coordinates. Okay, let's all right, let's look at this. Let's do this. Okay, minus 2 sec 3 and 2. Okay, obviously if you plot your coordinate here, you know that this is your x, isn't it? This is your y. So which means that this plot, all right, for x and y here, it will be in which quadrant? Which quadrant? Negative x and a positive y. Which quadrant? Quadrant what? Anyone? Quadrant?
True.
2, correct. It's in quadrant 2, right? Okay, x negative, y positive. It's in quadrant 2. Okay, so it's in quadrant 2. That means, you know that, all right, if you compute later on, angle must be in quadrant 2. So it must be logic. Okay, it must be logic. Angle must be in quadrant 2. Okay, so it must be logic. Okay, but quadrant 2 angle, it can be in terms of positive. Remember, angle can be in terms of positive, it can be in terms of negative, so it doesn't matter. Okay, so in this case, question just asks you to find polar coordinates. So maybe one answer from one people can be differ to other people depending on what you give us in terms of angle. Because remember I said polar coordinates, it has infinitely many coordinates, can be represented by many coordinates. So actually any point, any angle you can give us. But of course, it is suggested that whatever you get from your calculator, that will be the coordinate. That will be much easier rather than you think of the other way around. Okay. So if let's say angle given in terms of positive angle from calculator, you just give us straight away that particular answer. Or if the calculator gives us in terms of negative angle, just use that. Okay, don't try to like change from negative positive positive negative, because then it will be like tendency of making mistake is there if you try to change from whatever that the calculator gives you. Okay, straight away let's say we use the formula straight away to compute. This is the our formula just now that you need. Okay, when you are given when you are given, okay, x and y are given, so you want to find r and theta. So this is the formula that you are going to apply. R equals to square root of x squared plus y squared. Theta equals to tangent inverse. Okay, tangent inverse. Alright, but again you must make sure that angle is correct. So if you know angle is in quadrant 2, it must be logic. Because why? Because you have to remember tangent inverse. Alright, sometimes they may give you like a different, and they give you angle in maybe in the first quadrant and fourth quadrant. Okay, because remember tangent inverse again. I'm trying to compete my voice with the next door construction. I hope the noise here. I hope you can listen. Okay, back to this formula tangent inverse, because you remember when we did our inverse tangent, okay, in chapter 2, the definition of inverse tangent, remember the restricted domain for inverse tangent last time. The restricted domain for tangent inverse is angle in quadrant 1 and quadrant 4. Okay, angle in, so that means calculator will follow that restricted domain. Remember I mentioned last time, calculator will definitely follow the restricted domain. So the calculator sometimes, depending on what is the y and x, if it's a positive, calculator will give you angle in quadrant 1. If this one negative, calculator will give you angle in quadrant 4. So if let's say just now we said that our point coordinate is in quadrant 2. So when we want to find angle in quadrant 2, okay, you must use the concept of reference angle. Okay, you must use concept of reference angle to get the right coordinates. Okay, to get the right coordinates. Okay, let's look at this. Okay, let's look at this. Okay, let's compute this straight away from the formula. Okay, let me just write. Okay, so you have just now so you want to find polar. So that means you want the r and theta. So r is square root of your x squared plus y squared. Okay, so which means that x equals to your minus 2 3 the whole thing squared plus 2 squared. Okay, so what is this? So you have your 4, okay, times 3, okay, 12 plus 4, 16. So square root of 16, isn't it? Which is 4. Okay, can you double check? Because I don't have a calculator with me. All right. Okay? Understood? To compute for the R class? Okay, now you need the theta. Alright, so just now, tangent inverse y over x. If I make mistake in calculation, you just let me know, okay? Alright, tangent inverse, what is y just now? 2 over minus 2 sec 3. Okay, this is what I mentioned just now. Okay, this is what I mentioned just now. That calculator, when it comes to tangent inverse, if there's a negative, I'm sure the calculator will give you angle in quadrant 4, if I'm not mistaken. Can someone give me the answer from the calculator?
Negative 30.
Okay, so calculator give us negative 30. Okay, calculator gives negative 30. I hope everybody got this, minus 30. All right, don't straight away conclude, because this 30 is quadrant 4. Quadrant 4 angle, right? So it's a quadrant 4 angle. That means from the calculator, remember I mentioned if it's tangent inverse, if it's a negative, it will give you angle in quadrant 4. If it's a positive value, it will give you angle in quadrant 1 because of the definition of the restricted domain for tangent. Okay, but remember this coordinate, we said that it must lie in quadrant 2, because when you plot, all right, isn't that somewhere you go negative x and then positive, so you're somewhere here, that is your minus 2 3 2 is actually coordinate, that rectangular coordinate there lies in quadrant 2. So you must give us angle in quadrant 2, so not angle in quadrant 4. So if you straight away conclude that your r theta is 4 minus 30 degrees, that is wrong. Okay, so that is wrong. All right, because again, as I said, this is quadrant 4 angle, but the fact that the point here lies in quadrant 2, so that means you use your concept of reference angle. Okay, you use the concept of reference angle. That means this is 30 degrees. All right, that is 30 degrees. So what is angle in quadrant 2? Is this much, which is 150 degrees. Okay, which is 150 degrees, or you can say it's 5 pi. Oops. This is 150 degrees, or you can say 5 pi over 6. Okay, if I'm not mistaken, 5 pi over 6 in terms of radian. Okay, but it's 150 degrees. So you then only you conclude, therefore, all right, you can say like just now, polar coordinates of minus 2, or maybe not enough space, minus 2 sec 2 sec 3 2 are 4 and then 150 degrees, or you can say 4 5 pi over 6. Okay, it's already 12. It's already 12 o'clock. Maybe we can quickly, you can quickly try this, just the last one. Try B. You try B and see what you get. B is minus 2, B is 2 minus 2. Oh my, can you all hear me?
Yes.
Can you all hear me?
Yes, yes.
Because
Yes.
my somehow,
Yes,
because
madam.
okay, because somehow my screen here got stuck. It doesn't want to move. My screen got stuck. So it doesn't want to move. Okay, never mind. Just quickly give me the answer. Just to finish up. Then later, maybe next week I can just, maybe they ask me to stop already, isn't it? Because the screen doesn't want to, it doesn't want to scroll up. I'm scrolling up, but it doesn't want to move. I don't know why. But as long as you can hear me. Okay, the coordinate just now for B is 2 minus 2. Two minus 2. Maybe you can just shout me the answer once you finish. Just compute like what I did just now. Okay, R and theta, but make sure it's the right theta. Okay, what do you get for your R? R is square root of x squared plus y squared. So x is 2, so 2 squared, plus y is minus 2, but square it. So that means I have square root of 4 plus 4. So that means I have square root of 8, right? Okay. So square root of 8. That is my R. Either you write square root of 8 or you can write as 2 square root of 2. Okay, so that is R. Okay, my concern is the theta. Because tangent inverse y over x, because this is 2 minus 2, so definitely you got minus 1. Tangent inverse minus 1. Tangent inverse of minus 1, definitely calculator will give you negative 45 degrees. Am I right? Because the calculator will give you angle in quadrant 4 again because of the negative value. So calculator will either give quadrant 1 or quadrant 4, depending on whether it's positive or negative value for y over x. Okay, because of the definition of the restricted domain last time. So you have to find out first, 2 minus 2 lies in which quadrant? Okay, 2 minus 2 lies in quadrant 4, isn't it? So in this case, then perhaps it's very straightforward then. What will be the answer then? This one is straightforward because you don't have to change your angle from the calculator. Calculator gives you already angle in quadrant 4, and 2 minus 2, the fact that the coordinate is actually 2 minus 2, it lies in quadrant 4. So the answer should be 2 square root of 2 or square root of 8, and then comma. You can say straight away minus 45 degrees also acceptable. Okay, my screen stuck, so I cannot write. I don't think that you can see my writing. Okay. I don't think you can see my writing because my screen is stuck already. Okay, Afiq Daniel,
No,
what do you
madam,
mean
we
by
can't
this?
see.
Huh? What?
Your screen is not moving, mister.
That's why. My screen is not moving. My screen actually stuck. It is not moving. That's why I don't think you can see anything that I write here. But at least you can hear my
Yes,
voice.
exactly.
Okay. But you can hear my voice, right? Okay.
Yes, yes.
After all, it's already 12 o'clock. It asks us to stop actually. Okay, but do you get the answer? Just now I mentioned the R is square root of 8 or 2 square root of 2. And then the angle is minus 45 degrees. So you can write in terms of minus 45 degrees. All right, that's it. So that means coordinate will be square root of 8 or 2 square root of 2 and then minus 45 degrees. That's it. That is the polar coordinates. Okay. All right. Okay, everyone. I think I have to stop here since it's already 12 o'clock. Okay, it's already like 8 minutes after 12. So perhaps we can stop here. Okay. After all, my screen is not moving anymore. Okay, but did you all get me? Did you all get the answer?
Yes, yes, madam.
Okay. All right. Everyone
Madam, can I ask a small question, please?
can, but I cannot understand
Uh,
anything here, Saran.
no, no,
Okay.
no. Okay, for the first question, that the A1, why the answer is 150?
Why the answer is
150.
100, 150?
Ah,
Because you need to find angle in quadrant 2. Saran, do you
because
know that we need to
they
find
get
angle
quadrant
in
2.
quadrant 2? Yes. Because our coordinate minus 2, 3, 2, that one, the rectangular coordinate given for part A. All right. If you plot that coordinate lies in quadrant 2.
Oh, so
Correct
the
or not?
B is a 2, which means the answer will be in the quadrant 4 lah. That's why the answer is a negative
Yes.
45 lah. Okay, I understand. Okay,
Yes.
okay,
Yes.
okay.
2 minus 2 be in quadrant 4. So calculator will give you quadrant 4 angle. So you don't need to change. You can just leave it as minus 45. Or if you want to give us in terms of positive angle, what would that be?
Positive angle, which means it will be 135.
No.
Okay. Okay.
Quadrant 4. Quadrant 4.
Quadrant 4, it will be 45 lah. Kan?
I mean, if you do not want to give me minus 45, you want to
Oh,
give me in terms of positive angle in
okay.
quadrant 4, what would that be?
315 lah.
Yes, correct. Correct. Okay.
Okay, sir.
So B is either you say angle, that one is minus 45 degrees, or you can say 315 degrees in terms of positive angle. But angle must be in quadrant 4. So calculator definitely will give you quadrant 4. So that's why I said if you don't want to change, whatever calculator gives you, fine. For this B question, B part, because the coordinate itself 2 minus 2 lies in quadrant 4. So angle must be in quadrant 4. So calculator will give you quadrant 4 angles in terms of negative. But if you want to change to positive, can. Make sure it's correct, 315 angle. But like part A, because the rectangular coordinate given is in quadrant 2. Okay? So calculator will definitely give you quadrant 1 or quadrant 4 because of tangent inverse. Tangent inverse, because of the restricted domain by definition, angle, they will give you either quadrant 1 if it's a y over x is positive. If y over x is negative, calculator will give you quadrant 4. But when the coordinate is in quadrant 2 or in quadrant 3, you make sure you must give us the right angle that lies in the right coordinate. I mean the right quadrant. Okay?
Okay.
Okay, Saran?
Okay, Puan. Okay, Puan. Thanks.
Okay, so perhaps maybe next week I will show you the answer for this part B, because since my screen is actually not moving. Okay, so after all, it's already like 12 o'clock. So perhaps I end the session if anybody don't have any question anymore. Will that be okay? All right.
Okay,
Okay.
Syam.
Okay,
But
madam. Okay,
make sure you do your tutorial. Be ready for tutorial this Wednesday. All right. Okay, everyone.
Okay, madam.
Okay. All right. So perhaps we can end our session. All right, today. Thank you for your attention and thank you for listening, and sorry for any problems, all right, that arise over here. Okay, so I will meet you again on Wednesday morning, inshallah. All right. Okay, everyone. Okay, thank
Okay,
you.
madam. Thank you.
All right. Okay.
Thank you, madam.
Thank
Okay,
you,
you're
madam.
welcome. You're welcome.
Puan.
Yes.
Puan busy ke lepas ni?
Sorry, Saran?
Puan busy ke lepas ni?
No, I'm free.
Okay, I ada satu soalan pasal yang assignment tu. I tak tahu nak buat macam mana. I boleh
Oh,
tanya tak?
assignment question
Ah.
cannot lah, Saran.
Cannot
You
lah.
cannot ask
Okay, okay.
me. You cannot ask me unless how do I say something like no. Even if you ask me to explain, also you have to try to discuss with your group members first.
Group members lah. Okay lah, kena no.
Discuss with group members. Okay, then after submission only we can discuss.
Okay. Boleh,
Can
boleh.
Saran? Will that
Boleh,
be
boleh.
okay?
No problem. Boleh, boleh.
Okay. Sorry.
I already
Saran,
finished all
for this.
the questions. I don't know the first question. The B one. I stuck in there lah. That's why.
Okay. You
Okay, no
try
problem.
to discuss with your group members first, Saran.
Okay, can. Okay, can.
All right. Okay.
Thanks, Wan.
Saran. Okay. Welcome.